Hand 1, parametric equations. Let's go. No black pen, red pen guy. You're stuck with me explaining this stuff. Well, hopefully if you had a good trig teacher, probably most of y'all took me. I'm sorry, I didn't teach this to most of you. Parametric equations. So you might have seen this before. If you had a good pre-calc or a trig teacher that got through all the material, you would have seen some parametric equations. And they're really not that bad. This stuff's very reasonable. Now, let's just jump right into it. What the game is now is we're saying that our x is a function of time. Like, it's not that big of a deal for us to look over and see, like, y is equal to some function. Like, we always say that y equals f of x, except now we're not calling our variable x, we're calling it t, and I'm misspeaking right now. We're actually going to call that our parameter, hence parametric equations. But what we're trying to say is we now have that x is a function of time. Oops, I mean of t. Most of the time, it's easier for us to think about it by thinking that t is time. So we're going to just kind of say that our x value, can it change like over time? Like, just think about the position of something. If you move, then your x value would change as time went past. So could your y value with time. So this is going to allow us to graph things and to show things as time is passing by, not just as a stagnant or static graph. We can actually see it move. So here's the game. Our variable, oops, I mean parameter, is called t. So this is all going to be functions of t. Now, in order for us to do this, we need to make certain that both our f of t and our g of t have the same domain, at least on some interval I. And here we go. What's going on here is this is just a collection of points. Oops. It's just a collection of points defined by, well, when we're saying x comma y, it's some function of f of t and some function g of t. And it's called a plane curve. It's kind of the wording, the verbiage we're using is we're going to draw ourselves a plane curve. And I have one down here. It's already kind of graphed out. All of it called a plane curve, where t is our parameter. We gotta not misspeak this and call this a variable. It's a variable. We're gonna call it a parameter. It's a variable. So we're just gonna go through and deal with our parameter. Now, zooming in on our graph, let's look. So if we're going from some point A, right down here, some point A, and we want to go to some point B, what's nice about having a parametric is we don't just have this graph that sits by itself, it actually moves. You can see with the little arrows as we go past, it's telling us we're moving along in a direction. It's telling us as time is passing, our little curve is moving. It allows us to do so much more and actually have good, useful applications to it, because we know that there is that other dimension called time and things pass by. So now we can give it some arrows, or what we're going to call the arrows is actually our orientation. Okay, so it's the orientation, telling us which direction we're going. And we're going to need this when we graph. Very important. So where we're starting is down at A, and then we're going to B. Gives you the direction, right, from A to B along the curve, and we're going to graph some of those ourselves. So why don't we hop into that and start graphing on our own. So let's graph the curve defined by, and that's by the parametrics. Parametric, equations, EQs. X is equal to 3t squared, comma, y is equal to 2t. And we're going to keep our t values between -2 and +2. And I just got done telling you should think about time as t, right, to help you understand it. What's that, 2 seconds ago till 2 seconds after? It's kind of strange, but keep thinking about it like it's time. It kind of helps for, at least for me, to understand. Now we're going to graph the curves defined by the parametric equations. X is equal to some function of t. Oh, I mean, it's equal to 3t squared. Y is equal to some different function of t, which is just 2t, and we're going to keep our t's between -2 and 2. Now what I'd like for us to do is we're going to go old school right now. I hate to do this to you, but we're going to go kind of old school and just kind of do one of these. Let's go T, X, Y, and then we'll do some X comma Y. You know what I mean? We'll do something kind of like this, and we'll plug in our values of T, like -2, -1, 0, 1, and 2. And then, oops, why is it not working? There we go. There we go. Break those things up just a little. Okay, so let's just think. Now I don't need to plug all this stuff in, do I? So we think about this. So when we have -2 plugged into right up here, -2 into 3t squared, what's that going to become? -2 squared is 4. 4 times 3 is a big 12. So let's pop in a 12. And then when we take our -2 and we pop it into 2t, we're going to end up getting, what's that? That's going to be -4. Hence our xy is going to be 12 comma -4. Now let's pop in our -1 into both of them. One more time. We're going to go -1 into this and into that so we can pop our answers in. And what do we get? So -1 squared is 1. 1 times 3 is 3. -1 into the other one, we get -2. Hence we get the points. 3 comma -2. I'm going to speed up a little bit now. 0, 0. Just filling in this table, we're still going to get 3. This is going to pop out a 2. Next one's going to be, it's still going to be 12 because we're squaring that, and that's going to be a 4. So there we go. Look at all that collection of points. We got 5. We got 5 frickin' points right there. I'm pretty sure we could graph this thing up. But we must make certain that we talk about the orientation. We're moving in this direction. We're going from -2 to +2t. So we need to be mindful of this when we go to graph. So I'll just pop the dang thing up. Let's make ourselves a little graph right there. And what this is going to end up looking if we put our points in, I'm just going to call this 12. Am I going to need a 2? And I think a height of a 2 and a 4 over here will do sufficiently. A -2 and a -4. Sorry, not to scale, but we'll get it in. So what do we got? We got a 12, -4 is our first one. Our next one is, I put in a 2. Let's put in that as a, let's move this thing over. Back up, back up, back up. Let's just call that shit 3. We'll make a point there. And then we're going to have 0, 0. Then we're going to have 3, 2. And then we're going to have 12, 4. But this has orientation. We have a direction in which we're going. So we're going this way. As we, oops, I missed the dot. Just make the dot bigger. That's always been my trick. So we know we're going that way. Oh, I need to not have that there. I can't write an arrow at the end because that's as far as we're going. But now we draw our arrows telling ourselves that we're moving in this direction because we go from t is equal to -2 to -1. We have to make certain that we follow in this direction with our points right here. So please, when you graph them up, make sure to give us the orientation. You got to say with the arrows as to which direction it's going. So here's the beginning of our parametric curves. Now, if I was in your situation, I would probably do your homework. You know what I mean? You're going to get a lot of good practice. I think most of the problems we do for any sort of testable stuff will be right along in lines of what you see in your homework in the Stewart text. Give it a shot.